Hello everyone, welcome back to Sine Data Math. Today we're going to be going over important trigonometric identities and properties, plus some practice problems. So I will be leaving this image in the description for your convenience, and it basically contains all of the trigonometric functions, identities, and properties that you will need. So firstly, we see that sine squared plus cosine squared is equal to 1, 1 plus tangent squared is equal to secant squared, and 1 plus cotangent squared is equal to cosecant squared. These will help you in proving some trigonometric identities in the future, so memorize these. Next, we have every basic trigonometric function except for cosine x and secant x have the following property, which is f of negative x is equal to negative f of x. So basically, if I took sine of negative x, I'd get negative sine of x, or if I took tangent of a negative x, it'd be negative of tangent x. And if we have cosecant or cosine of negative x and secant of negative x, it will just be the same as their original function. So as you can see, cosine of negative x is equal to cosine of x, and secant of negative x is equal to secant of x. So let's say I had sine of negative 3, it'd be the same thing as negative sine of 3. But if I had cosine of negative 3, it'd be the same thing as cosine of 3. Next, if you have a basic trigonometric function and put pi over 2 minus theta as the input, you will get the cofunction of the original function. So basically, if you have sine of pi over 2 minus an angle theta, you will just get cosine theta because cosine is the cofunction of sine. And if you have tangent of pi over 2 minus an angle theta, you will get cotangent of theta because cotangent is the cofunction of tangent. And if you put pi over 2 minus theta as an input into a cofunction, you just get the original function. So if you put pi over 2 minus some angle theta into cosine, you'd get sine because sine is the original function of cosine. And then if you put cotangent of pi over 2 minus some angle theta, you get tangent of theta. And at the bottom here we have a few quotient properties that you will just have to memorize. I'm not going to be going over all of these, but they will be in the image linked below. Anyways, let's get started on our challenge, or not our challenge, practice problems. Our first question asks us to find sine and cosine if tangent is equal to 1 over 5 and sine is positive. And we're supposed to be using Pythagorean identities. So firstly, let's evaluate what we have. We have tangent of theta is equal to 1 over 5, and we want to find sine and cosine. Okay. Now we know that sine is positive, and since tangent is equal to sine over cosine, if sine is positive, that means that cosine also has to be positive. Because if cosine was negative, then tangent would be negative, because positive number divided by a negative number will just be a negative number. But since tangent is positive, that means that cosine must be positive, so that we have a positive number divided by a positive number, and we get a positive tangent. Okay, so now let's think back to our trigonometric properties and identities. What identity includes tangent? Well, that would be 1 plus tangent squared is equal to secant squared. Now here, we can replace tangent squared with this tangent right here, which would be 1 over 5, and then we square that. Because tangent squared is just tangent to the second power, we can plug in this tangent and just have to square it. So we will get 1 plus 1 over 5 squared is equal to secant squared. Now we can square this. We will get 1 squared on the top, which is just 1, and we'll get 5 squared on the bottom, which is just 25. And that's equal to secant squared theta. Now I'm going to rewrite this 1 right here as 25 over 25, and we'll keep this 1 over 25 right here. This will equal secant squared theta. And we can see that secant squared theta is just going to be 26 over 25. Now what we can do is take the square roots on both sides and we will get that secant theta is equal to the square root of 26 over 5, because the square root of the top is just the square root of 26, and the square root of the bottom is just square root of 25, which is 5. Okay, great. So now that we have secant of theta, we can flip it and get cosine of theta, because remember, secant theta is equal to 1 over cosine theta. So in order to get cosine of this, or in order to get cosine from this, we just flip the fraction. So we'll get that cosine of theta is equal to 5 over the square root of 26. But most of the time we will be asked to rationalize the denominator or get rid of the square root on the denominator. So we'll have to multiply by the square root of 26 on the top and bottom. And we'll get 5 times the square root of 26 over 26, which is our cosine value. So I will just write that cosine of theta is equal to 5 times the square root of 26 over 26 at the top here. Now, how do we find sine? Well, we can now use another trigonometric identity. I'm going to erase this. You can rewind if you need to see this work, but I'm going to use another trigonometric identity now involving cosine, because now we have a value for cosine. And what's that? Well, now we can use sine squared of an angle theta is equal, sorry, not equal, plus cosine squared of an angle is equal to 1. Now, just like we did with the 1 plus tangent squared, we're going to plug in our cosine value into this cosine squared. So we'll get that sine squared plus cosine squared, which is going to be this number squared, 5 times the square root of 26 over 26 squared is going to be equal to 1. Now we can square this out. We get sine squared theta plus, if you square this out, you'll get the top squared, which will be 25 times 26 over 26 times 26. I'll write it as 26 times 26 because that's the same thing as 26 squared. So we can just cancel out one of these 26's. And that'll be equal to 1. So now we can see that sine squared theta plus 25 over 26 is equal to 1. Alright. Now we can subtract this 25 over 26 to the other side, and we'll get that sine squared theta is equal to, I'm going to rewrite this one as 26 over 26 minus 25 over 26. And we can simplify this down to 1 over 26. And now we can take the square root on both sides. And we'll get that sine theta is equal to, the square root of the top is just 1, and then the square root of the bottom is the square root of 26, which is equal to square root of 26 over 26 if you multiply the square root of 26 on the top and bottom. And there we go, we have our sine value right here. We can write sine of theta is equal to square root of 26 over 26. There we go. Okay. Now our next question asks us to evaluate, or to find tangent of theta and cotangent of theta if secant of theta is 8 over 3 and sine of theta is less than 0. So this sine theta is less than 0 is very important, because that means that we will have a negative tangent value and a negative cotangent value. The reason being is because this secant theta is going to be positive. And the only way we can, and if we have a positive cosine value, because secant is 1 over cosine, which means that if secant is positive, then cosine is positive. Let me write that out. Since secant theta is equal to 1 over cosine of theta, that means if secant theta is positive, that means that cosine of theta is positive, because we have this positive 1 on the top, if secant of theta is positive, we have to divide by a positive number, so cosine has to be positive. All right. So that means that if we have cosine being a positive value, then if we have tangent, which is sine over cosine, that means that if sine is negative and cosine is positive, that means that tangent will be negative. And the same goes for cotangent. I will let you guys figure out the reasoning for that, but so we have to just remember that we have two negative values. Okay. So now, what trigonometric property will we use here? Well, we know the value of secant theta, so I want to think of one of the trigonometric identities that uses secant, which is 1 plus tangent squared theta is equal to secant squared theta. Now, just like the last question, I'm going to plug in this secant theta right here and the secant squared theta, and we get 1 plus tangent squared of theta is equal to 8 over 3 squared, because we just plug this in and we have to square it. Now I'm going to square this out, and we will get the top squared, which is 64, over the bottom squared, which is 9. And I'm just going to, and now we're going to subtract this 1 on both sides. So we get tangent squared of theta is equal to 64 over 9. And I'm going to write this 1 as 9 over 9. The reason I'm doing that is because 1 will just be 9 over 9 if you simplify that down. And now we can see that we will get tangent squared of theta is going to be 64 minus 9, which is 55 over 9. I'm pretty sure I did that right. Yeah, okay. So now, if tangent squared theta is equal to 55 over 9, we can take the square root on both sides, and we will get that tangent of theta is equal to the square root of 55 over the square root of 9, but the square root of 9 is just 3. But remember, our tangent value has to be negative, so we have to put a negative sign in front. Another way you can think of this is that if you took the square roots right here, you'd have to do plus or minus, and you just take the minus version of it. But right here, we're just going to skip that and just put a minus sign because we know that our tangent has to be negative. Okay? So, actually, I should just show that method because it might be a bit more helpful. So we'll get that tangent of theta is equal to plus or minus the square root of 55 on the top, and then the square root of 9 on the bottom, which will be 3. But since tangent is negative, again, we just take the negative version, and we'll get negative square root of 55 over 3. Alright? So now that we know that, remember that, okay. Now we have to think, okay, now that we have our tangent value, what can we use to get cotangent? Remember that cotangent of theta is equal to 1 over tangent theta. So we can just flip this fraction and we'll get that cotangent of theta is equal to 3 over negative square root of 55. And then we can multiply on the top and bottom by negative square root of 55. So that on the bottom those cancel out and we just get a 55. The square roots cancel out. And then on the top we get negative 3 square root of 55. And this will be our answer. Our next question asks us to use identities to find the value of the expression. If sine of theta minus pi over 2 is equal to 0.73, find cosine of negative theta. So this one combines both the complementary trigonometric function property and the negative angle identity for cosine, sine, and all that. So firstly, we have sine of theta minus pi over 2. But we want this to look like sine of pi over 2 minus theta, because then we know that this is just equal to cosine theta. Okay, so how do we make this pi over 2 minus theta? Well, pi over 2 minus theta, or theta minus pi over 2 times negative 1. If we distribute this negative 1, we get negative theta plus pi over 2, which is equal to pi over 2 minus theta. because since it's addition, you can just swap theta and pi over 2. But since we multiplied by a -1, we have sine of negative theta minus pi over 2, which is equal to sine of pi over 2 minus theta. But since we multiply by this negative, this is also equal to negative sine of theta minus pi over 2. Reason being is because if we have sine of a negative angle, it's equal to negative times the sine of that positive angle. So to find the value of this, we have to take this and multiply by -1, and we'll just get negative 0.73. Because this is sine of theta minus pi over 2. If you multiply that by a negative, then we have to multiply the output by a negative, and we'll get negative 0.73. But since all of these are equivalent, we have negative 0.73. But remember that sine of pi over 2 minus theta is equal to cosine of theta. So we know that cosine of theta is equal to negative 0.73. But we want to find cosine of negative theta. But this is pretty easy because we know that cosine of negative theta is just the same as cosine theta. So the answer to a problem is that cosine of negative theta is just going to be whatever cosine of theta is, but cosine of theta is negative 0.73. And there we go. That's our answer. Our next question asks us to use basic identities to simplify the expression. Now, in order to do this, you have to remember some of the quotient rules and some of the identities. But what we need here is we need to write tangent of x as a quotient of two functions, or a function over a function. Now remember that tangent of x is equal to sine x over cosine of x, and we have to multiply that by cosine of x. But wait, if we have cosine of x in the denominator, and then we multiply by cosine of x, the cosine of x's will cancel out, and we'll be just left with sine of x. And that is the answer to our question, just sine of x. So you write tangent of x as sine x over cosine x, and you multiply by this other cosine x right here. And the cosine in the denominator and the cosine right here will cancel out, and you'll just be left with sine of x right here. And that's the answer. Our next question asks us to complete the identity. Now this one looks a bit tricky because we have this cosine squared and then this letter here that looks like a b. It's beta. I'll call it b for simplicity. But this is actually pretty simple because negative cosine squared of the b looking thing, actually, I don't know, I'll call it b and beta, plus 1. Well, here's the thing, we can just swap the 1 right here and we'll put the negative cosine right here, and we'll get 1 minus cosine squared of beta. But this looks familiar because if you remember, sine squared theta plus cosine squared theta is equal to 1, right? And if I subtract cosine theta, or cosine squared theta on both sides, we'll just get sine squared theta is equal to 1 minus cosine squared theta, which is the exact same thing we have right here. It's just that theta is beta, the b. So this is actually equivalent to sine squared of whatever this is, the b, so beta. All right? So this is equivalent to saying sine squared of beta over negative sine of beta. But here's the thing, if we have sine squared on the top and then another sine on the bottom, well, this is like sine to the first power, right? So if we divide sine squared over sine to the first power, we just subtract the powers. So we'll have, we'll take this negative right here, right here. We'll put it in the front, and then we'll have sine square root of, actually no, I'm just gonna do this right like this. So sine beta, and this squared will cancel out with this on the bottom, because this is kind of like writing sine beta times sine beta over sine beta, and you can cancel them out, and we'll just be left with negative sine of beta, and that's the answer to our question right here. So firstly, you take this equation on the top and rewrite it to 1 minus cosine squared of beta, and then figure out that that is equal to sine squared beta using the trigonometric identity sine squared of some angle plus cosine squared of the same angle is equal to 1. And then write the equation like this and cancel out the sine squared with the sine on the bottom, and you'll be left with this negative sine of b, which is your answer. Our next question asks us to simplify the expression. So firstly, we have tangent of negative x, and I'm going to write that as negative tangent x, because remember, tangent of negative x is equal to tangent, or negative tangent of x, okay? And then we have tangent of pi over 2 minus x. Now remember, if we have tangent of pi over 2 minus x, this is the same as writing the co-version of that. And the co-version of tangent is just cotangent of x. So I'll write this as cotangent of x. Alright, now what I'm going to do is I'm going to write both of these in terms of sine and cosine. Now we know that tangent of x is equal to sine x over cosine x, and we know that cotangent of x is equal to cosine x over sine of x. So I'm going to write this as negative sine x, this negative moves down here, sine x over cosine x times cosine of x over sine of x. Now here you can see we have a pretty good simplification. This sine will cancel out with this sine, and this cosine will cancel out with this cosine, and we will be left with just this negative as negative 1, because it's kind of like negative 1 times all of this. And since all of this cancels out, we will just be left with negative 1, which is the answer. Alright, our next question asks, what is the simplified form of sine theta plus 1 times sine theta minus 1? Now the easiest way to do this is just to multiply the entire equation out. So we'll do sine theta times sine theta, and we'll get sine squared theta, because anything times itself is just itself squared. And then we'll do sine theta times negative 1, which will be minus sine theta. Now we'll do 1 times sine theta, which will be plus sine theta. And then we'll do 1 times negative 1, which would be just minus 1. Okay. So now we can see that this minus sine theta and this plus sine theta will cancel out, because if you have minus x plus x, it'll just be 0. I feel like that should be obvious. And we will be left with sine squared theta minus 1. Now this looks very familiar. Again, if we have sine squared theta plus cosine squared theta, it's equal to 1. Now, how do we get sine squared minus 1 out of this? Because remember, we want to find a simplified form for this. Well, firstly, let's subtract 1 on both sides. So sine squared theta plus cosine squared theta minus 1 is equal to 0. And now let's subtract cosine squared theta on both sides. And we will get sine squared theta minus 1 is equal to minus cosine squared of theta. So there we have it. We have sine squared minus 1 right here, and we have sine squared minus 1 right here, but that's equivalent to negative cosine squared of theta. And that is the answer. So just use the trigonometric identity to rewrite sine squared minus 1 in some form after multiplying this form out. Okay. Our next question is make the suggested trigonometric substitution, then use a Pythagorean identity to write the resulting function as a multiple of a basic trigonometric function. That's a mouthful, but let me show you what it's asking. So basically, it wants us to plug in x as 2 times secant of theta, okay? So right here, I'll rewrite this as the square root of x squared minus 4. Now, if we plug in this x value, it'll be 2 times secant theta squared minus 4, okay? Now, if we square that out, this 2 times secant theta, we will get 2 squared, which is 4, and then we'll get secant squared, which is just secant squared minus 4. Now, both of these have a common factor of 4, so I can factor a 4 out inside of the square root, and we'll get secant squared theta minus 1. Now, I can rewrite this as the square root of 4 times the square root of secant squared theta minus 1. Now, we'll see that the square root of 4 is just 2, and then times the square root of, well, what's secant squared theta minus 1? Recall, we're supposed to be using a trigonometric identity, and 1 with secant theta is just 1 plus tangent squared theta is equal to secant squared theta. Now, if we subtract 1 on both sides, we will get tangent squared theta is equal to secant squared theta minus 1. And right there, we have a simplified version of secant squared minus 1. And we can plug that in right here. And we'll get the square root of just tangent squared theta. Now, the square root of tangent squared theta is not just tangent theta, it's actually the absolute value of tangent theta. Because the square root always has to be positive. And inside, we can't just cancel it out. We have to have like the absolute value of tangent theta. So, we get 2 times the absolute value of tangent theta. Because if we had a negative number in here, it wouldn't really work out. Because then we'd have the square root of something, like, so the square root of like some number would equal a negative something, and we can't really have that because the square root is always positive. So we have to have this absolute value out here. And there we go, that's our answer. 2 times the absolute value, this bar means the absolute value of tangent theta. Alright, and that's because if we can't just cancel out the square root and the squared, we have to write it as an absolute value because the square root always has to be positive, and the absolute value will make sure that it's positive. So right here we just plug in the x for this x value and we get this. We expand it out, we factor, and then we use a trigonometric identity to simplify. Right. So the next one asks us to find all solutions to the equation. Now right here, we have both of these terms have a sine theta. So I'm going to factor out a sine theta from this entire equation. If we factor out a sine theta from sine squared theta, we'll just be left with a regular sine theta. And then we factor out a sine theta from this, we'll just get the minus 6 because then we divide this entire thing by sine theta, and this will cancel out, so we'll just get negative 6, okay? I will erase that. Now we have to set one of these equal to 0, so either of these have to be equal to 0. So firstly, we'll get sine theta is equal to 0, or sine theta minus 6 is equal to 0. But this implies that sine theta must be equal to 6, because if we add 6 on both sides, we'll get sine theta equals 6. But if you remember the graph of sine theta, you remember that it's bounded between 1 and negative 1, right? Like it's like this, just like this curve, you know, like, sorry, that's a horrible curve. You know, like it's this this curve, and it's always in between negative 1 and 1. Why am I drawing this so bad? But you get the idea. It's always going to be in between this area. It's never going to be greater than 1, and it's never going to be less than 1. Remember, it's just going to be this curve, you know, just going in between. It's a very bad sine curve, but you get the idea. But since sine theta has to be less than or equal to 1, and less than or greater than or equal to negative 1, because of the graph, you know, it's always in between negative 1 and 1, sine theta can't be equal to 6. So we just ignore this part. Sine theta can't be equal to 6, meaning that this part is never 0, so we ignore it. And we move on to this. Now recall, when is sine theta equal to 0? Well, that's whenever theta is a multiple of pi. So pi, 2 pi, 3 pi. So we'll have pi, 2 pi, 3 pi, 4 pi, and also 0 is in there because 0 times pi, it's a multiple of pi. But we can simplify this. We can write it as theta equals n times pi, and we can write that the n is equal to 0, plus or minus 1, plus or minus 2, and so on and so forth. And you can just put dot dot dot. And that would be the answer to this question, because that's the only time where sine theta will be equal to 0. And the other part won't be equal to 0 at all. So this is our only answer. Our next question asks us to find the solutions to the equation. And we see that we kind of have a weird equation right here. We have cosine of x squared, and we have cosine of x. But in reality, this is just like a hidden quadratic equation. And we'll see that if we make a quick substitution. Now, I'm going to set cosine of x equal to some variable, and we'll do it as cosine of x is equal to y, okay? And then if we square both sides, we'll see that cosine squared of x is equal to y squared, okay? Now, I'm going to rewrite this entire thing in terms of this new substitution y, right? So we'll have 4 times cosine of squared of x, but cosine squared of x is just y squared. And then we'll have plus 4 times the square root of 2 times cosine of x, but cosine of x is equal to y. So we'll write y plus 2 is equal to 0. Now it's a bit clearer that we have a quadratic equation, you know. We have this times y squared plus this times y plus 2. Now, you can use the quadratic formula for this, and I think I'm going to do that because I feel like everyone knows the quadratic formula. And we'll get minus 4 times the square root of 2 plus or minus the square root of 4 times, I think I should write this up. A is equal to 4, B is equal to 4 times the square root of 2, and then C is equal to 2, just so that we have this. And the beginning is negative B, and we'll have plus or minus B squared, and B squared is going to be 4 squared times the square root of 2 squared, which is just equal to 16 times 2, which is equal to 32, I believe. Yeah, 32. So I have 32 minus 4 times A, which is 4, times 2. Now, and then we put it over 2 times A, which is 4. Now, if we simplify the square root, we'll have 32 minus 4 times 4, which is 16, times 2, which is just equal to 32 minus 32. That's just equal to 0. So this entire square root is just canceled out. And we'll have negative 4 times the square root of 2 over 2 times 4, which is 8. And we can simplify this down to negative 1, or negative square root of 2 over 2. Okay? So, well, let me write out the steps. So if we simplify negative 4 over 8, it's just going to be negative 1/2, and then we have the square root of 2, and then we can put the square root of 2 on the top. So we'll have negative square root of 2 over 2. Now, this means that we have y is equal to negative square root of 2 over 2, right? Because you do the quadratic equation, that means that y is equal to this quadratic formula. Now, and remember that y is equal to cosine of x, so we have to find out when cosine of x is equal to the negative square root of 2 over 2, all right? Because we found out when y is equal to 0, but originally we wanted to find when cosine of x is equal to 0, and y is equal to 0 when cosine of x is equal to 0. So cosine of x must equal negative square root of 2 over 2. Now, if we think about it on a unit circle, the only time cosine is negative is in quadrant 2 and in quadrant 3, all right? And if we look at a reference triangle, we'll see that cosine of 45 degrees is the square root of 2 over 2, because cosine is adjacent over hypotenuse. So it'll be 1 over the square root of 2, which is the same thing as the square root of 2 over 2. Well, we want the negative version of that. So we have to find out what the reference angle for 45 will be in quadrant 2 and quadrant 3. And if you don't know how to find that, in quadrant 2, it's going to be 180 minus whatever angle you're trying to use. So in this case, it'll be 45. And in the third quadrant, it'll be 180 plus whatever angle you're trying to use, 45. Okay? So 180 minus 45 will give us 135, and then 180 plus 45 will give us 225, okay? So we only want when x is equal to 135 degrees or when x is equal to 225 degrees. But normally on a test or on like a Math Excel, it'll ask you to put it in like radians, so like pi over something. And the way we can do that is by multiplying 135 by pi over 180. And we multiply 225 by pi over 180. Now you can simplify this down. I'm just going to plug it into a calculator real quick. So 135 divided by 180 is going to be 0.5 or 3/4 times pi. So 3 pi over 4, which is one solution. And then 225 times pi over 180, which will be 5 over 4 times pi, which will give us our other solution, which is 5 pi over 4. There we go. So our solutions are when x is equal to 3 pi over 4 and when x is equal to 5 pi over 4. There we go. This one is a bit confusing because you have to convert it to another variable and then do all of this calculations, but if you rewatch it and just follow the steps, it should be pretty easy to follow. Alright, our next question asks us to prove the identity cosine squared x minus 1 over cosine of x is equal to negative tangent of x times sine of x. Now, we're going to start off with this left-hand side, so cosine squared of x minus 1 over cosine of x. Now, let's simplify this numerator, cosine squared of x minus 1. Now remember, we're going to use the same identity. Sine squared theta plus cosine squared theta is equal to 1. Now, if we subtract the 1 on both sides, we'll get sine squared theta plus cosine squared theta minus 1 is equal to 0. And then if we subtract the sine squared on both sides, we'll get cosine squared theta minus 1 is equal to negative sine squared theta. Okay? And there we go. We have a simplified version of this numerator. So we can rewrite this as negative sine squared x over cosine squared x. Now I'm going to rewrite this as negative sine of x over cosine of x times another sine of x. Because remember, sine squared of x is sine x times sine x, so I'll just write one of the signs on top and then the sign to the left. But here we can see that we have sine over cosine, which will give us tangent of x, but then we drag down this negative and we'll get negative tangent of x. So we'll get negative tangent of x times sine of x, which there, we have our identity. So firstly, we simplify the numerator, and then we split it up into a fraction that we know, and then just whatever else we have, and then we simplify into tangent of x, negative tangent of x times sine of x. Now I think we have a few more questions. This one should be pretty straightforward. So remember, sine squared theta plus cosine squared theta is equal to 1. And if we subtract sine squared theta on both sides, we'll get that cosine squared theta is equal to 1 minus sine squared theta. And right here, we can just plug this back in, and we will get cosine squared x over this denominator. But this denominator is just 1 right here from this identity. So it's cosine squared x over 1 but that's just equal to cosine squared of x. And there we go. This one is pretty simple. You just have to simplify the numerator and the denominator using the same identity. Alright, this next one is establish the identity. It's another proof one. And what I'm going to do is I'm going to rewrite tangent and secant into sine and cosine. So tangent will be sine u over cosine u, and then secant will be 1 over cosine of u. Now you see these both have the same denominator, so I can rewrite this as sine of u minus 1 over cosine of u. Alright? Now, what I want to do is I want to multiply by the conjugate of sine u minus 1 on the top and bottom. And what I mean by that is we just flip this sign in the middle right here. So you see how we have sine u minus 1? I'm going to multiply by sine u plus 1 on the top and bottom. And this way, when we multiply this out, we get sine squared on the top plus sine squared plus sine u minus sine u minus 1, if you just expand that out. And then we get cosine of u times sine of u plus 1 on the bottom. Now, as you can see, we can simplify this numerator. Those sine of u's will cancel out. And if we think back to our identity, I think I've shown this a few times, but sine squared theta minus 1 will just be equal to negative cosine squared theta. So we can replace this with that, and we'll get negative cosine squared theta, or cosine of u in this case, cosine squared of u, over cosine of u times, and I'm going to rewrite this as 1 plus sine of u. It's the same thing as saying sine of u plus 1. I'm just going to flip the order, 1 plus sine of u. And now you can see we can cancel out this square on the top with this cosine of u on the bottom, and we'll get negative cosine of u over 1 plus sine of u, which is exactly our identity. So rewrite everything in terms of sine and cosine, then multiply the top and bottom by a conjugate so that we can hopefully get somewhere to use a identity where we have a square, and then simplify. Alright. I think this is our last question. Yeah? Okay. Find all the solutions in the interval 0, 2 pi. Now, we are given tangent squared of x is equal to 3. Now, what we can do is we can immediately just take the square root on both sides, and we'll get tangent of x is equal to plus or minus the square root of 3. And the reason is because when we take the square root on both sides, tangent of x could be the square root of 3 squared, and it'll give us 3, or negative square root of 3 squared. They're the same thing. So, when is the tangent of x equal to the square root of 3? Just the positive square root of 3. Well, if you look at a 30, 60, 90 triangle, if we have 60, we have the square root of 3 on the bottom, 1 on the side, and then 2 on the top. Remember, tangent is opposite over adjacent, and the 60, the opposite will be square root of 3, and the adjacent will be 1, which is equal to square root of 3. So we already know one of our solutions, because that's where tangent of x is equal to square root of 3. So I'll write that down, 60 degrees. But there are actually 3 more solutions. And the reason being is because we can go to the other 4 quadrants on a unit circle. So, we have this quadrant, which is 1, this quadrant, which is 2, this quadrant, which is 3, and this quadrant, which is 4, right? In each of these quadrants, we will get tangent of x being equal to the square root of 3 or the negative square root of 3. Now, if we want to find where it's the square root of 3 in the other quadrants, we have to use the reference angle formulas for each. And I'll write those down right here. So if we want to go from quadrant 1 to quadrant 2, we have to use 180 minus whatever angle we had here, which is 60 degrees. Right here, we have to, when we go down from quadrant 2 to quadrant 3, or quadrant 1 to quadrant 3, we have to do 180 plus whatever angle we're using, which is 60. And if we want to go from quadrant 1 to quadrant 4, we do 360 minus whatever angle we have, which is 60. Now 180 minus 60 is going to be 120. So that's another one of our solutions. And then right here, this is going to be 240 degrees, which is, yeah, 240 degrees. And then here we have our last one, which is 300 degrees. And those are the 4 solutions to our problem. But as you can see, we have 2 pi right here, and in Math Lab or Math Excel, it'll probably ask you to put it in pi, like a form with pi. Now, we can easily do that by seeing that 60 degrees, just remember that 60 degrees is pi over 3. And then 120 is the same thing as 2 pi over 3. 240 is going to be 4 pi over 3. And then 300 is going to be 5 pi over 3. And there we go. Those are all of our solutions. And I think that's it for this review. Hopefully you guys enjoyed, and hopefully this helped with a bit of the tricky proofs and tricky questions on the Math Excel. I know a lot of people struggled with it today. I heard a lot of things like, just some of this is just too confusing. So hopefully some of this clarified it, and hopefully this graphic that I made simplified a few things for you. Alright, that'll be it. Hope you guys enjoyed. I know this was a very long video, but there's a lot of steps that I wanted to go through, and hopefully everything was clear. Anyways, good night. Sine Theta Math out.